we are just having knowledge of the other services, but still we remain independent, right? And how we will ensure that we will have knowledge of the other services, or which other principle will satisfy this requirement of loose coupling? In a sense, you can also say that I'm asking you a question. Loose coupling requires which other principle to be fulfilled? Okay, I'll give you the list of principles if you just want to go for that. Reusability, contract, loose coupling we can ignore, right? Underlying logic, composability, autonomy, statelessness, discoverability. Now, I think one thing should be clear in your mind, that loose coupling is a core principle, right? So if it is dependent on something, it has to be again a core principle, yes or no? That makes sense? Okay. Now, so what are the options we are having, right? Autonomy, abstraction, and contract, right? Autonomy says that we have control over the logic, right? But that won't affect the coupling aspect, right? You are talking about the internal aspects of the service, right? Abstraction is again possible to achieve if your contract is published. Are you getting what I'm saying? Abstraction is possible if contract is published. So I think we have our answer. Which principle loose coupling has to be dependent upon? Yes. Autonomy is out of question because it is focusing on the internals of the service, right? Abstraction is dependent on the contract, as I said. So what is the answer? What is the remaining principle? That yes, right? It's an easy guess, we can say, right? So it is the contract, right? If contract is properly published, right, then we can be aware. Okay, I'll repeat, Priyank, don't worry, right? See, how do we maintain or how do we become aware of the other services? I think we covered this as the second lecture of SOC, right? If you want to be aware of other service, what you require is wisdom. Agree? Yes, Priyank? Yeah. So wisdom is a part of contract. Can I say that? Hence proved, if you want to be just aware of other services, right, we want its contract to be published, right? So if I have the contract of the service, then I can do communication. Okay, so that is why we say that having knowledge of other services, that means we must have the contract, still remain independent, because see, you will not be calling that service immediately. You will be studying the contract and then you will be calling the service, right? That is the mechanism we are having. Are you clear with this now, Priyank? Yes, again, we'll be discussing this when we, okay, then in which how loose coupling affects. Yes, yes, yes. See, you will be calling that service, right, through the use of contract. I hope you are clear with that statement. You will be calling that service using the service contract. Okay. Now, once you call that service, are you going to remain connected to that service for a longer period of time? No, right? You will be writing all the context information in the SOAP message, yes or no? And that burden is shifted to the SOAP message, right? Here. So, but for calling that service, what was my requirement? What is the first requirement I have to satisfy? Or to remain loosely coupled, what is the first requirement I have to satisfy? Is it contract? Are you getting it now? Yes. Yes. And now statelessness will come into picture as you answered, right? But that is the second case, right? First, what we need is contract. I hope it is clear now, right, Priyank? So we'll be discussing all these things, right? We'll see relation between principles, and at that time, we'll have a lot of discussion on this. Okay, fine. So I have one statement. Let us go through that. Loose coupling is achieved through the use of service contract, right? That allows services to interact within predefined parameter. That means within predefined operations and their parameters, we can communicate with that service. Okay, so I think this statement is clear now. What I discussed was about all this statement, right? Is it fine to all? First statement. I'll discuss the second one now. Okay. Can't loose coupling be using statelessness too? Yes, but I cannot say that loose coupling depends upon statelessness, right? Yeah. So that is why it is using, it's fine, right? It is not dependent on that, right? And as I said earlier also, statelessness is generally given by your frameworks, right? Whatever framework you are using. Like if you talk about your RESTful services, are they stateless by default? The APIs that you are creating, are they stateless by default? Yes or no? Okay, what is HTTP? Is it a stateful protocol or stateless protocol? Let us talk about your CN concepts, right? It is a stateless protocol, right? Yeah. So can I say that in that case, we are by default stateless? Yes or no? So I don't have to worry about statelessness, right? If I'm implementing SOA through APIs, right? I hope you're getting the point, right? Urjit, Priyank, Janil, Abhi, right? Yes. If statelessness is not maintained, then it will achieve loose coupling. Okay, that's a good question. Statelessness is required, right? I agree to that, right? But I cannot say that it is dependent on, you can say loose coupling is dependent on statelessness because it is automatically achieved by the framework. Is that fine, Priya? So that's why we are not saying that it is dependent. Okay. See, some principles have to be realized by programmers, right? While some principles come automatically, mostly statelessness will come automatically, right? That's why I'm saying that it is not dependent. Okay. Yes. Now this statement is interesting. It is interesting to note that within a loosely coupled architecture, service contracts actually tightly couple. Understand this blue part. Service contracts actually tightly couple operations to services, right? What I mean to say is, written in the next line, when a service describes its operations, other services become dependent on that, right? So it is very simple. Suppose you are having an employee service. An employee service is providing you 4 operations: add, update, get, and delete. Okay. So can you call any 5th operation out of or except what is defined in the contract? No, right? So can I say that I'm becoming connected to that contract, or I'm becoming dependent on what is defined in the contract? I'm becoming dependent on what is defined in the contract. Yes or no? Yeah. So that is what this line says. Service contracts actually tightly couple operations to services. So your service requester becomes dependent on the operations of the provider. Are you getting the statement? Service requester becomes dependent on the operations of the provider, but that has to be there, right? Okay, but can we say that it is going to violate your loose coupling principle? Can we say that it is going to violate your loose coupling principle? No, right? Because anyway, contract has to be obtained first. You have to read the contract, right? Why we are doing all this, complexity? Because we don't want to remain connected to that service forever, right? We are having discovery mechanism. Okay. So internally we are having, you can say, a sense of tight coupling, right? But when you look at the bigger picture, right, it is like this. See, now I think this picture would be clear. When you are calling the operation, you are remaining connected to that, right? Or you can say that you are dependent on that service operation. Okay, and that's why there is a straight line. But where there is a dotted line, between the logic. Are you getting this figure now based on this statement? Right? This is a very, very important statement, right? never mug up the theory, right? As I said earlier, many times, right? You can be asked a logical question based on that, right? True, false, or even you are given 4 correct statements and 1 incorrect statement. You should be able to locate that. That's why I'm spending a lot of time on discussion, right? Plus, that is not enough. Yeah, sure, Ujit. See, try to compare this with the statement. What we said over here, service contracts tightly couple operation to services. So whenever you are calling an operation, this double arrows is nothing but you are calling an operation. Is that fine, Ujit? So when you call that operation, we are forming a connection. Can I say that? Or can I say that I am becoming dependent on that operation for just that much time? Right? So at that level, we are having connectivity. But what is not dependent? Our logic. And that's why you can see a dotted line. Understood? Right? Okay. So this is very, very important. And that's why I said that loose coupling is the most important principle. Right? But now you have a loophole. Right? Loose coupling also depends on something. And what is the answer to that? Again, we'll discuss this, but I think you have got your answer, right? Loose coupling also depends, or it also requires something that has to be done before we achieve loose coupling, that is contact. Correct, Prince, right? Is this figure clear now to all? Right? Okay, so that's why I said this is an interesting statement, and I hope I have justified it, right? Okay, let us switch to the next principle, abstraction. Is abstraction a core principle or a major principle of SOA? Yes. Why? We should know the answer, right? We cannot mug up again the list of core principles and list of non-core principles. Why something is called core? We should know that, right? So why abstraction is important? Because in SOA, we talk about standards always, right? Now that standard may be XML, JSON, or any other data format, right? Which is accepted by all, right? When can you communicate with, you can say, or in other words, when can you communicate in a standard manner? Only when you abstract out your logic. Yes or no? Because if you are showing, yes, exactly, right? If you are showing your implementation technology outside, right, then only the clients which can understand your platform will be able to communicate, right? We want uniformity, okay? And that's why abstraction is a core principle. Understood this point? Right? And it has to be realized. It has to be coded in such a way, right? This will not come by default. Abstraction will not come by default. Okay, fine. Let us go in detail. Service abstraction is also known as service interface level abstraction, right? No matter what programming language you are using, right? Either it is a C# or Java, right? We have the concept of interface, right? So what we show is interface. What we back to that, right? Why did we call it black box? Suppose you want to check whether factorial function is working fine or not. How would you test it? You don't know the logic, correct? What you know is input, and what you know is expected output, right? Yes, that's correct, Urjit, right? So similar to that, when you abstract your logic, right, your services will be just be acting as black boxes, right? What you will show is the gateway or your interface, right? In WCF, you have studied that as ABC. Remember that concept? Address, binding, contract. Those 3 things are nothing but your gateway to the service, right? So abstraction is very, very important, right? Let us go for the second point. Scope of the logic represented by a service significantly influences design of the operations, right? See, if your logic is dependent internally, right? If your logic is having lot of dependency, that is one function is calling the second function is calling the third one, you're having a chaining mechanism, right? Will you be able to share your contract in a better way if that is your design? Yeah, I'll repeat. Suppose you are having chain of calling, right? Whenever your service requester calls one operation, then that second one operation will be calling the second internally, it will be calling the third internally, right? And then finally your data will be received, right? Is that a good way of designing? Having calling mechanism many times? No, right? So that is known as the scope of your logic. Your boundary of the logic has to be well defined, right? You should not have too much calling, right? Whenever you are receiving a request from the requester, you should not have too much calling, right? So that's what is important over here. If you want proper abstraction, your operations have to be properly designed. Is this statement clear? I'll repeat. If you want proper abstraction, operations and their signatures have to be properly decided. Is that point clear? Right? And that is why, if you remember, I said that an important topic that every programmer should know, that is known as design patterns. Right? Has anyone explored that? Now I think you are at home and you might be getting a little bit more time. Right? If not, do that before you face your interviews. Right? So how to design your operations or classes in a standard way, that you can learn by learning design patterns. Okay, so we'll do that during the break time, right? It will be helpful whenever you will appear for the placements, right? Okay, fine. So next is services can encapsulate varying amount of logic, right? We have seen this earlier in the second or third lecture. A web service can contain just one function. It can contain 2 or 3 functions, or it can also contain entire module, right? And I would say that all 3 designs are correct. Yes or no? Either you are encapsulating only one function or you are encapsulating multiple functions. It depends upon your requirement, right? Ultimately. So this is where abstraction is important, right? Even if you are hiding only one function, still your interface has to be properly published. Okay. That is what this third point is discussing about. Are you all clear with this particular slide? We have seen the black box concept. Abstraction depend on other principles. Yes, we'll soon answer that. Right now, I'm not investing time on that because we have that topic upcoming, right? So we'll take up that, right? So abstraction depends on others, and abstraction requires support of which principles? We'll see both sides of the coin. Right? So that is a complete topic we'll be seeing, right? Okay. Fine. So you can see one example. Service, it is encapsulating 2 operations. You can see there are 2 rectangles. That means there are 2 operations and there are 2 databases, right? And finally, what you are showing is just accounting operations. You have that update account or delete account operation, right? But what we are hiding from the clients, that we are having 2 modules, right? And there are 2 databases. Are you getting? What you are exposing is just the operations, right? Internals are hidden. Okay, so this is an example of abstraction. Although we have written only one operation over here, update account, but it can be a complete account service, right? Bank account service. Okay. Whatever statement I said over here, that is this second point, is reiterated by this third statement. Operational granularity is a primary design consideration for abstraction, right? So if you design a fine grain operation, right? Fine grain operation, that means it is just taking primitive data types, integer, character, string, right? And it is taking only one parameter, right? And on the other side, you have a coarse grain operation, right? Coarse grain can include an object as a parameter or at least 4 to 5 parameters, right? In both the cases, we have to take care of abstraction, right? Either you are sharing or either you are accepting a single parameter or you are accepting multiple parameters, as well as you are expecting an object, right? So whenever you think about abstraction, make sure that your operations are properly designed, right? So basically, the burden will be on programmer, right? Programmer has to define the signature of the methods properly, right? Based on that, the granularity will be decided. I think you remember this concept, right? Fine grain and coarse grain. We had discussed this earlier also. Yes, is that fine? So ultimately, if you want to achieve abstraction, which component of your web service has to be designed properly? I'll reiterate my question. If you want to achieve proper abstraction, which part of your web service or which component of the web service has to be designed properly? Is it the service? Is it the operation? Or is it the message? The answer is there over here. It is operation. Yes, that's correct, Ronak. Right? I hope you agree, all of you, right? Operation and its signature plays a critical role based on what you hide and what you show. Right? Because ultimately, based on that operation signature, your interface will be created. Yes or no? You all are doing that kind of programming, right? So operation design or operations granularity is a very, very important aspect. Okay. Let us look at the last bullet point. Loosely coupled communication structure requires that only piece of knowledge that services need is service description. Okay. And how do we share service description? How do we share service description? Using contract, correct. And I am asking one more question in the same line. Contract will be created based on what? Or in which case contract will not be possible to create properly? The answer is same for both the questions. First question, contract will have to be, or contract will be created properly if dash is designed properly. Okay, can I say that? Loose coupling, okay. Indirectly, I would say that is correct answer, not directly. See, ultimately your operations designs have to be proper. If operations design is proper, your abstraction would be proper. If abstraction is proper, contract would be properly shared. Are you getting this chain? Yeah. I'll repeat once more, right? If operations are designed properly, contract design is proper, right? Yes, Surjit, I'll go back to that figure. And if contract design is proper, then we'll be able to, okay. Now let me see your question. Look, indirectly achieve abstraction so that, yes, abstraction is, you can say, correct. Abstraction is indirectly achieved while you try to achieve loose coupling. Agree to that. I hope that is your point, right? Yes. So that is where we'll be discussing, right? All those relations, right? Okay. It's good that you are thinking on the lines and you are able to relate with other principles. Okay. Let us look at the example, right? So what you see as dotted boxes over here, right? We have a pair of requester and provider over here, right? So service requesters have no idea what lies beyond a service provider. Yes or no? Is that correct? You have, let us say, invoice submission is having the WSDL of account service, and purchase order service is having the WSDL of order service. But are we aware that there is a ledger service available? There is a vendor profile available on the other side. Are we aware about that? Are you getting this point? I'm just knowing one service on the other side, right? Can I say that that is also abstraction? Okay, I'm waiting for the replies. Yes, right? It is one type of abstraction, isn't it? But this abstraction would be called what? It will be called service level abstraction, right? You know only the entry service, the other services are hidden to you, right? So that is another example of abstraction, right? Clear? Okay, so abstraction hides the logic as well as it can also hide the other services. Are you getting both the advantages? Yes, Urjit, Priyank, Prince. Okay, yes. Fine. So let us now go for the next one. Now we'll take a simpler principle. Composability is a non-core principle. We'll see why it is so, right? In the next topic. So let us first go through that definition. What do you mean by composability? A service should be able to take part in composition as and when required, right? So, as an example, we have seen that multiple times. Account service is calling the vendor profile service, right? Based on demand. It is calling the ledger service based on demand. It is calling the notification service based on demand, right? Is it remaining connected to those services all the time? Yes, I'll answer that question. That's an interesting question. Yes, surely, Urjit. But let me first cover this part. When account service is invoking the ledger or vendor profile service, is it going to remain that to that service forever, or it is going to be calling on demand basis or on requirement basis? On demand, correct, right? So basically, what I can say is, account service is composing vendor profile and ledger service at runtime. Yes, yes or no? It is called runtime composition, right? Whenever you receive an invoice, right, you have to call that service, right? So that is at runtime, fine. But we have seen one more concept that defines composability at design time, and that is orchestration. Yes, coordinate when needed, right? That is a dynamic behavior. But orchestration defines your process service, and process service contains, remember that switch, flow, while, all those things, right? So over there, we are defining the composition statically. Yes or no? If this condition is true, I'll be calling service A, else I'll be calling service B, right? That is defined at design time. Okay. So remember one point, composability can be of two types, runtime composability and design time composability, right? Runtime composability can occur depending upon your requirement. While what is the example of design time composability? Orchestration. Clear with this much? Yes? Okay. Now, Urjit, let me take your question. How the abstraction is maintained if company has the WSDL? Yes, see, basically, if you don't obtain the WSDL, will you be able to communicate? If you don't obtain a WSDL, no, right? Now, after sharing WSDL, am I showing my code or I'm just sharing my interface details? No, right? So can I say that abstraction is maintained because I'm not exposing my code? I'm just exposing my interface, right? I hope you are getting the point. So abstraction is maintained, right? Because we are not showing in what language that code is written, right? We know which service are there. Yes, but when do we come to know that? When we search, when we explore, right? Yeah. So we have discovery mechanism, right? That is why loose coupling will also come into picture. Are you getting? All principles are mixing up over here. Yeah. So that is why we need to study that concept, interrelation. Okay. Is it fine now? Okay. Is there any benefit of design time composability over runtime? Yes, Vishrut. There is a definite advantage because see, at higher level, your logic is always hard coded, isn't it? Because depending upon the scenarios, suppose you are clear that after you receive the invoice from the company, right? You have to call first vendor profile service. Once vendor profile returns, you have to call the ledger service. Once ledger returns, you have to call the notification service. If that path is predefined, right? then would it be better if I write that as orchestration? The condition is it is predefined, right? If path is not predefined, then yes, definitely you will go with the dynamic composition. But I would say that design time composition would be more useful, right? Yes, more principles are achieved at runtime. So good for our application. But that is the ideal situation, right, Urjit? We cannot expect dynamic behavior all the time, right? So some part of your logic has to be, you can say, coded internally, right? Okay. So this is choreography is also design time. Yes, yes, correct, Prince. Because over there also we are defining the workflow, right? Workflow logic. Or you can say work units, sorry, not workflow, work units, right? So that's why it is a design time again, right? Okay. But to implement a complex business task, always the path is predefined, right? So that's why orchestration and choreography are very popular, right? Okay. So just have a look at this, right? We are talking about composability. And suppose you are having three legacy services, right? One legacy service is providing you updating the account details. The other legacy service is providing you updating the history. And the third legacy service is providing updating of logs, right? Now, if you don't want to expose these three legacy systems outside, can we compose them as a single service? Yes or no? You can see that update everything, right? Ultimately, what this update everything will do, it will take the input from the user side. It will see that user is interested in calling which service internally, and it will accordingly call either account or history or logs, right? So this is also called composability, right? One service is composing multiple legacy applications, right? Got the idea? So composability comes in many forms, right? That is what I wanted to discuss, right? Okay. Fine. An interesting statement. Composability is another form of reuse. Agree? Ultimately, when you are composing a service, are you reusing it? For example, account service is calling vendor profile to validate first invoice. When it will receive the second invoice, it will be calling the vendor profile once again. So when I'm composing vendor profile multiple times, am I reusing that service? Yes, right? So hence we can say that composability is another form of reuse, right? And if you want your reuse to be properly designed, right, your operations have to provide generic interface, right? I think you have studied that in multiple programming languages, how to pass generic parameters. Have you learned that in multiple languages, right? Ultimately, you need to typecast, right, later on. But what you expect will be the generic parameters. Okay, so what? Yes, in C++ you have the concept of template, correct, right? So basically, this is again an ideal achievable thing. We cannot pass generic parameters to every operation, but as much as possible, we should do it, right? Because if we keep the parameter type generic, it will be more reusable, right? Having such type of compatibility with reusing services to call. Yes, I agree. But we can't throw away the legacy application, right? And what if these three are written in different languages, right? Then we have to design a standard interface for it. Yeah, so we are saving cost, right? Yes, ultimately. Okay, so I just gave you this example, right? You already know that. I don't need to go in detail. Account service is composing vendor profile and ledger, seen multiple times, right? Okay, clear up to this now? Composability principle clear to all? I hope you are finding this interesting, right? We are discussing all theory, but basically these are the concepts that will be useful when you will be coding your services, right? Okay. Autonomy. we need to discuss this in detail. Autonomy is an important principle, right? Autonomy requires that range of logic exposed by a service exists within a specific boundary, right? So suppose you say that I am having a bank account service, right? So that will be having fixed number of operations, right? Create account, add up, update account details, delete account, right? View account details, and so on, right? So the boundary is fixed. Are you going to maintain, uh, modify customer profile within the account service? Are you going to store that as an operation? Change customer profile as a part of account service? No, right? So if you do that, that means you are violating the boundary. Are you getting the example? Right? And you have learned this in object-oriented programming, how to group operations into classes, right? So I think that is known to you, right? So if your operations are grouped properly inside a class, we can say that your service would be more or less autonomous. Yes or no? Your drawn class diagrams, right? Even for your SDPs, you might have prepared them, right? So yes, grouping of operations is important, right? Okay. It also eliminates dependencies on other services, right? If grouping is proper, you don't have to depend on other services. It is not like that I'm storing update account details in one service and create account in the other service, right? Or even delete account in the other service, right? Because if you do that, that will inhibit the service deployment and evolution. So if you are having too much dependency at time of deployment, you need to be very careful, right? Because you know that these two services are connected. So they have to be deployed together. Fine. Evolution means changes, right? Changes would be difficult if we are having dependencies, right? So that's why now I think I have justified why autonomy is a core principle. Are you getting the idea? Right? So it is a very, very important principle, right? As far as the SO is concerned, as well as any programming language is concerned. Right? Let us look at this quoted statement. Autonomy is a primary consideration when deciding how the application logic should be divided, right? And which operation should be grouped together. There are 2 points. I think we have discussed the second underlying point. If you group your operations together properly, then only autonomy would be possible. Clear with that much? Second underlying part, right? Grouping operation into class, right? Very simple concept, you know. And before that, before you decide which operation belong to which class, you need to know how your logic is divided, right? Suppose it is a standard shopping application. Autonomy depends upon composability. Okay, we cannot say that directly right now, but I'll answer that when we'll see the difference, right? When we'll see the. Okay, I got your point, Dul. It is not depends, yes. But we'll see, we'll answer that later on, right? If we achieve autonomy indirectly, then we achieve, yes, Prince. We can say that, yes, right? Okay, and that is why I've kept that topic reserved, right? Relation and dependencies across principles, right? So what questions you are answering or you are asking will be answered during that, right? Dependent operations are deployed together. Yes, correct, right? So your logic should be divided properly, right? So when you design any application, let us talk about the standard shopping example that we have seen in the software engineering subject, right? So you keep order related methods in the order class, you keep customer related method in the customer class. So basically we are dividing the logic in a standard way, right? Are you getting this or not, right? So if you do that, ultimately what will be able to achieve? Autonomy, right? Because logic will have less dependencies, and that's how autonomy would be easy to achieve. Got this point, this statement, right? Okay, can we go ahead? Yes. Okay, fine. So let us look at the example from the book. You have a service that is hiding the internals, right? So upon execution, service has governance over its underlying application logic, right? So service knows what it is containing. Basically, this slide is telling you that this service, which is exposing one operation, it knows what it is hiding, right? So it can control the execution at runtime. It is not dependent on any other service, right? That's what this figure says. Okay, fine. Let us go for autonomy means more scalable. Yes, exactly. Because autonomy means less dependency. Less dependency means scalability, right? Correct. Okay. Let us look at two more points. Then we'll go for the last principle that is left out. Differing. This is interesting. Let us understand. Differing the location of business rules is one way to strengthen autonomy. And it also keeps the services more generic. Differing the location means instead of storing business rules in the service itself, let us store the business rules in a separate service that we call as a process service. Right? What will be the benefit of that? Storing the business rules in a separate service. What will be the benefit of that? The easiest thing we can say is my service does not have to maintain business specific rules. So can I say that my service is becoming generic because it is not remaining or remembering specific rules, right? So let us reiterate this statement. Now I think we will understand. Differing, that means storing the business rules in a separate location will increase autonomy. Do you agree with this? Right? And we have the answer to that. Yes, business rule. So as I said, whenever you receive the invoice, right, from the client, you have to first call the vendor profile service. That is a business rule. Are you getting? Right? Now, instead of maintaining that in my service, it's better to store that to process service, right? And I'll consult process service, what I need to do next, right? That would be better. Fine, because if I remember that rule, I will become customized, right? Yes or no? Yeah. Okay. Then the next one. Autonomy does not necessarily grant a service exclusive ownership, right? That it encapsulates, right? This I will answer after we cover these two types of autonomy, right? That will be more clear later. So autonomy comes in two flavors. Like composability comes in basic two flavors, right? Design time and run time. Similarly, autonomy is also divided into types. First is service level autonomy. In case of service level autonomy, service boundaries are distinct from each other. That means each service has complete control over its boundary, right? But those two services may share underlying resources. And by underlying resources, what I mean is database. Isn't it possible that two services might be sharing a common database in a real world scenario? Yes or no? You might have coded that kind of applications also, right? So that is known as service level autonomy, right? At service level, you are independent, but you are sharing something. Okay? Clear with this part? Service level autonomy? Let us now take a look at what is pure autonomy. Pure autonomy says that underlying logic is under complete control and ownership of the service, right? That means everything that you have is belonging to you only, right? Nothing is shared, neither underlying applications that you are hiding, neither underlying resource that you are hiding, right? Fine. So which is better? Tell me. What is ideal achievable? Service level autonomy or pure autonomy? ideally, or if we think practically, I would say service level autonomy should be used. But if you are designing a pure SOA, right, where you want everything to have complete control, even over the resources, then pure autonomy would be the answer, right? But in practical situations, we go for service level autonomy. Is this clear? Right? Now, I think you have seen this statement. Pure autonomy should be used when a new service is being built. Now, why I have written this? Because when you are writing your logic fresh, you should keep pure autonomy in mind. Right? Because if we keep pure autonomy in mind, we can have total control over everything. Right? But when you are hiding a legacy application, in that case, can we achieve pure autonomy? When we want to encapsulate 2 or 3 legacy applications, can we achieve pure autonomy in that? No, right? Because those legacy applications might be sharing their code, they might be sharing the databases and other resources, right? So in that case, which kind of autonomy we can achieve? Which kind of autonomy we can achieve? For legacy hiding, service level autonomy, right? Correct. Clear with the difference? Pure autonomy means can be deployed together, and service level, it can be different. Yes, you can say that, right? Correct. Pure autonomy means complete control, right? You are not sharing anything, right? Once a call comes to you, you are neither dependent on someone to respond. You will respond it yourself, right? Service level can be more scalable. Yes, that's why I said it is practical, right? So we'll actually have, whenever you design an SOA, you will have a mix of service level autonomy and pure autonomy. That would be the ideal thing, isn't it? Right? Where you don't have dependency, you go for pure autonomy. But where you are sharing something, you go for service level. That's okay, right? Fine. Now let us go through that statement. It will be clear. Autonomy does not grant a service exclusive ownership of logic. So internally, your logic or resources can be shared. Yes or no? Right? And where it can be shared, in which kind of autonomy? In which kind of autonomy your logic or the resources or applications can be shared? At service level autonomy. Correct. Right? And that is why we have 2 types of autonomy. Okay? Fine. Clear? Orchestration can be complex in service level. Correct. Because in that case, you have to actually deal with connected services, or you can say services which are sharing the resources. So orchestration management will be difficult. Absolutely correct. Right? Okay, can we go for statelessness now? Yes? Okay, so again, we have discussed this many times that we have to maintain minimum amount of state information, or I would say ideally 0 amount of state information, right? Because if you maintain or if you become stateful, right, you will not be loosely coupled, you will not be autonomous, right? Okay. So this is again an important principle, but it is why it is not a core principle, because as I said, statelessness can be achieved by programming platforms, as well as statelessness depends on many other principles, right? On the depending side, there is a long list. That's why it is not a core principle. But it is not like that it is not an important principle. Okay? Let us go in detail. Service should minimize the amount of state information they manage and duration for which they hold. Duration is very important, right? Ideally, we want a fire and forget kind of mechanism, right? Remember that MEP? Fire and forget? Because if you use fire and forget, you will be immediately available for the next request, isn't it? You will be immediately available for the next request. And that's why we prefer that kind of mechanism. But See, when you have submitted an invoice for your processing, right? Then you have to wait until your reply comes ultimately, right? So sometimes you have to maintain connection, okay, till your reply comes back, and that is which kind of MEP? Request response, right? We have seen that. Okay. So while this is again an interesting statement, while a service is processing a message, it is temporarily stateful. Yes or no? Because see, when you are processing a message, that means you are reading that message, right? And you are reading that message that is coming from some company X, right? So you have to remember that I'm processing the invoice of company X, or I'm processing invoice number so and so at this point of time, right? So during that short period of time, I am remaining stateful. Yes, correct. Connected to that service for a while, right? So while you respond to that service, you are stateful. Yes, fine. So that is required, right? We do not say that over here statelessness gets violated. Okay, this is requirement. Okay, understood the statement? Okay, what will happen if you remember state for a long period of time? If a service, okay, SOAP header contains state information. So messages are stateful. Yes, Prince, correct. Right, but by making the messages stateful, services will be less stateful. Can I say that? Yeah. Okay. If a service is responsible for retaining state for longer period of time, its ability to remain available to other requesters will be impeded. Right? This is very important because if you maintain state for longer period of time, you will not be serving other requesters, right? And that will decrease the efficiency, right? So that is why statelessness is recommended. Okay. Fine. So this proves the second statement which we have seen. Once you receive the message, right? When you receive that message, you are stateless, right? But while you are processing that message, right? So receive message A, interpret the message, process it, and forward or respond, right? While you do all these things, you are stateful. Okay. But once you send the response, again you go back to stateless. Step number 3, yes or no? So this is the ideal scenario in an SOA based service, right? While you process that message, yes, you are stateful because you are doing specific processing. But once you respond, again, you will become someone who does not remember, right? Okay. Let us complete this statelessness principle by looking at the other statements. Statelessness is a preferred condition for services and the one that promotes reusability and scalability. Obviously, if you are stateless, you will be more available. Yes or no? You will be more available. And if you are more available, can I say that you are reusable? I hope you are able to relate, right? And if you are more available, you are scalable as well, right? So statelessness increases other aspects, right? Okay. For a service to retain as little state as possible, its operations need to be designed with stateless processing. See, everything goes to the ground at operation level, right? Ultimately, your code has to be designed in such a way, or your operations have to be designed in stateless manner, right? Because if your operations or your logic is stateful, then your service cannot be stateless. Yes or no? So ultimately, who will be the person in charge over here? The programmer, right? Okay, let us look at the last one. A primary quality of SOA that supports statelessness is document style messages, right? I hope you remember that difference. We have seen RPC style and document style. In RPC style, we are just passing parameters, right? The message size will be very less. We don't write intelligent information in the message. While in document style message, we insert a lot of SOAP headers, right? So the message size would be heavy. But what will be the benefit of that? Even if the message size is heavy, your services will not have to remember the state information, right? So in SOA, yes, correct. It stores the state information, right? The more intelligent information added to the message, more independent and sufficient it remains, right? Now I think the circle completes. I hope you are getting why we say that messages should contain as much information as possible, right? Because we want to achieve autonomy, we want to achieve statelessness, right? You're getting all this, right? Is it summing up, or is it is getting confusing? I hope it is not getting confusing, right? Okay. Fine. Last one. Discoverability. Let us finish this and we'll stop, and I'll cover interrelation tomorrow, right? So discoverability helps avoid redundant services, right? Suppose you already have a very good weather service or very good accounting service. So rather than designing a fresh service, we can simply consume it, right? We might have to buy that service, that's okay. But rather than constructing a fresh service, will it be better if I just consume that readily available service, right? So discoverability is very important. I gave you that statement in the class also. If you design a very good service, but if you don't share it, nobody will come to know that you have designed a very good service, right? So advertising is very important, and that is what is achieved by discoverability, right? We don't have too much to discuss over here, right? But tomorrow I'll be starting with this relations, right? Service orientation principles are related to each other. How and in what manner? That is going to be interesting. Okay. Thank you. We'll end this session for today. Tomorrow we'll continue with this. Okay. Have a nice day ahead.